There is a place at the bottom of the world where the wind never truly stops, where the temperature drops so far below zero that exposed skin begins to freeze within minutes, where the sun disappears for months at a time, leaving behind a darkness so complete it feels physical. This is Antarctica, the coldest, driest, and most isolated continent on Earth. And yet, somehow, humans decided to build a city here. McMurdo Station sits on the southern tip of Ross Island, perched on volcanic rock above the frozen expanse of McMurdo Sound. It is the largest research station on the continent, capable of housing over 1,000 people during peak summer season. It has roads, vehicles, a harbor, a fire station, laboratories, dormitories, a greenhouse, and even a coffee shop. It is, by any reasonable measure, a small town, built in one of the most hostile environments our planet has to offer. To understand why McMurdo exists, you have to go back to the 1950s, to a world still raw from the Second World War, where two superpowers were competing for dominance across every domain imaginable, including the frozen South. In 1955, the United States Navy launched Operation Deep Freeze, a massive logistical effort to establish a permanent American presence in Antarctica ahead of the International Geophysical Year of 1957. The mission was scientific in name, but strategic in ambition. The Soviets were planning their own Antarctic stations. The race was on. The Navy sent icebreakers, cargo ships, aircraft, and thousands of sailors and construction workers. They called it the most difficult construction project in American history. They were not exaggerating. The first crews arrived to find nothing. No harbor, no roads, no shelter. Just rock, ice, and wind. The challenge began before a single nail was hammered. Everything needed to build McMurdo, every beam, every generator, every bolt, every tube of toothpaste, had to be shipped from the continental United States to the bottom of the world. There were no local suppliers. There was no backup plan. If something was forgotten, it stayed forgotten for at least a year. The supply chain for McMurdo is one of the most complex logistical operations on Earth. Each year, the United States Antarctic Program coordinates what is known as the Annual Vessel Resupply, a precisely choreographed effort involving cargo ships, fuel tankers, icebreakers, and military transport aircraft. The planning begins more than 12 months in advance. Every single item is cataloged, prioritized, and loaded in reverse order of need. The voyage south takes weeks. Ships travel from Port Hueneme in California or from Littleton in New Zealand, crossing some of the roughest seas on the planet. The Drake Passage, the stretch of open ocean between South America and Antarctica, is notorious for waves that can reach 20 meters in height. Containers shift, equipment gets wet, and the ship keeps moving south. When the vessels finally reach the Ross Sea, they must wait for the annual sea ice to break up sufficiently to allow passage. This is where the icebreakers come in. Heavy vessels with reinforced steel hulls and massive engines, designed to ram through ice several meters thick. They carve a channel, and the cargo ships follow behind, inching their way toward the station through a corridor of fractured white. Watching an icebreaker work is one of the most visceral engineering spectacles you can witness. The ship does not sail around the ice. It drives directly into it. The bow rides up onto the surface, and then the sheer weight of the vessel, tens of thousands of tons, crashes down, shattering the ice beneath. The sound carries for miles across the silent, frozen sea. Once the supply ships reach the ice pier at McMurdo, the real work begins. The ice pier itself is a feat of engineering, a floating dock constructed from seawater that has been deliberately frozen over several seasons into a platform thick enough to support heavy cranes, vehicles, and the weight of continuous cargo operations. It is rebuilt or reinforced every few years, because even in Antarctica, ice does not last forever. The construction of McMurdo's original buildings in the late 1950s was carried out largely by United States Navy Seabees, the military's construction battalions, famous for their ability to build infrastructure in extreme and hostile conditions. These men worked in temperatures that regularly fell to -30 or 40 degrees Celsius, in winds that could knock a person off their feet, in conditions that no civilian construction crew would have tolerated for a single day. The first priority was shelter. Without insulated buildings, nothing else was possible. The early structures at McMurdo were basic, prefabricated panels bolted together over wooden frames, heated by diesel stoves, barely adequate against the Antarctic cold, but they were enough to keep people alive and working. Antarctic construction requires a complete rethinking of everything you think you know about building. The ground beneath McMurdo is not soil. It is permafrost, volcanic rock, and compacted earth that behaves differently under load than anything found in temperate climates. Drive a foundation too deep into frozen ground, and the heat from the building will begin to thaw the permafrost beneath it, causing the structure to sink and tilt. Engineers had to design buildings that sat above the ground on adjustable pilings, allowing cold air to circulate underneath and keep the permafrost frozen. Every pipe carrying water or waste had to be insulated to prevent freezing. In Antarctica, an uninsulated water pipe exposed to outside air will freeze solid within hours. McMurdo's utility corridors, the networks of pipes and cables running between buildings, are themselves enclosed structures, heated and maintained year-round. Even the act of supplying a building with water requires a small engineering project of its own. The station's power needs are enormous. At peak operation, McMurdo consumes electricity equivalent to a small American town. For decades, this power was supplied by a small nuclear reactor, the PM-3A, installed in 1962, one of the first portable nuclear reactors ever built. It operated for a decade before being decommissioned due to concerns about radiation leakage into the surrounding rock. Today, the station runs on diesel generators, massive industrial machines that run continuously, consuming millions of liters of fuel each year, all of it shipped in from the north. Fuel is, in many ways, the lifeblood of McMurdo. Without it, the generators stop, the heat goes off, the water freezes, and the station dies. The annual fuel resupply is treated with the same urgency as food and medicine. Large bladder tanks store the diesel in flexible rubber reservoirs spread across the station grounds. A dedicated pipeline system connects the fuel storage to the pier, allowing tanker ships to offload directly into the station's storage without requiring individual drums or containers. In 1989, a fuel spill at McMurdo released approximately 95,000 gallons of petroleum products into the surrounding environment, contaminating soil and threatening the fragile Antarctic ecosystem. The cleanup took years and cost tens of millions of dollars. It prompted a complete overhaul of how the United States Antarctic program handles hazardous materials and accelerated the push toward better environmental practices across all Antarctic operations. Antarctica is protected by the Antarctic Treaty System, a set of international agreements that designate the continent as a natural reserve devoted to peace and science. Under these agreements, strict environmental standards apply to all construction and operations. Nothing can be dumped into the environment. Waste is categorized, processed, and shipped back north. Even sewage, for much of McMurdo's history, was discharged directly into McMurdo Sound, a practice that would be unacceptable today. Modern wastewater treatment facilities now process all liquid waste before any discharge occurs. Building anything new at McMurdo today involves a level of environmental review that would be familiar to planners in any major city, and then some. Impact assessments must consider not just the immediate construction footprint, but the long-term effects on soil, air, water, wildlife, and the experience of other researchers working in the area. In one of the most pristine environments on Earth, every decision carries weight. The station's infrastructure has been rebuilt and modernized several times over its 70-year history. In the early 2000s, the United States Antarctic program launched a major modernization effort, consolidating dozens of aging, inefficient buildings into fewer, larger, better insulated structures. Old buildings were demolished and their materials carefully sorted for shipment north. New buildings rose in their place, modern, energy efficient, designed for a century of service in conditions that would destroy ordinary construction within a decade. The Albert P. Crary Science and Engineering Center, completed in 1991, is the crown jewel of McMurdo's infrastructure. At nearly 4,000 square meters, It is one of the largest scientific facilities in the Southern Hemisphere. It houses laboratories for geology, glaciology, biology, atmospheric science, and ocean research. Its design accounts for Antarctic conditions at every level. Triple glazed windows, heavily insulated walls, roof lines engineered to shed the fierce katabatic winds that periodically scour the station at speeds exceeding 100 kilometers per hour. McMurdo's airfield, or rather airfields because there are several, represents some of the most unusual aviation infrastructure on the planet. The primary runway during winter operations is carved directly into the sea ice of McMurdo Sound. Known as the ice runway, it exists only during the Antarctic winter, when the sea ice is thick enough to support the weight of large military transport aircraft like the C-17 Globemaster. Engineers measure the ice thickness daily. When it drops below a safe threshold, the runway closes. When the sea ice begins to break up in spring, the runway simply ceases to exist, consumed by the advancing melt. A second airfield, known as Pegasus, is built on the permanent ice shelf rather than sea ice, allowing year-round operations, at least in theory. The blue ice runway at Pegasus requires constant maintenance. Antarctic winds carry abrasive particles that scratch and erode the surface. Summer melt, even in Antarctica, can create surface irregularities that make landings hazardous. Crews work continuously to resurface, inspect, and maintain the runway, using equipment specially modified for polar conditions. Life inside McMurdo is unlike life anywhere else on Earth. The station runs on a rhythm dictated not by convenience, but by survival logistics. Meals are served at fixed times in the central galley. Sleep schedules rotate with the endless summer sun or the total winter darkness. The social dynamics of a small, isolated community, where the same few hundred people share every meal, every corridor, every recreational space, are intense in ways that outside observers rarely appreciate. The people who come to McMurdo are not ordinary workers. They are scientists, support staff, engineers, mechanics, cooks, and medical personnel, all selected through a rigorous screening process that evaluates not just professional qualifications, but psychological resilience. Antarctic winterovers, the small group who remain at the station through the months of complete darkness and isolation, undergo particularly thorough psychological assessment. The polar night, the confinement, the knowledge that evacuation is effectively impossible for months at a time. These are not conditions that suit everyone. And yet, people return. Season after season, decade after decade, veterans of the ice come back to McMurdo. There is something about the place, the scale of it, the silence of it, the sense of being somewhere genuinely beyond the ordinary world, that exerts a pull that is difficult to explain and harder to resist. McMurdo Station today is more than a research outpost. It is a living demonstration of what human engineering can achieve when the stakes are high enough. It is a testament to logistics, to planning, to the sheer stubborn insistence on making something work in a place where everything conspires against it. The wind still howls across Ross Island. The temperature still drops to levels that freeze breath before it disperses. The darkness still descends for months at a time. But the lights of McMurdo Station burn on, through the winter, through the storms, through the long polar night. A small, stubborn, extraordinary city at the bottom of the world.